Hello, I'm Jason with ScienceandMath.com, and today we're going to learn how to do something that you probably have seen in a tourist shop or on vacation somewhere if you've gone to the beach, and that is how to make an ocean in a bottle. So what we're going to do is put some things into a sealed bottle, and it's going to look like the ocean with waves and everything else. It's very simple to do, and there's some science behind why it works and why it looks the way it does, so it's very, very fun. All you need to do this is you'll need some sort of oil from the kitchen, some sort of canola oil or corn oil or something like that. You'll need a bottle to, to make your ocean in, so something that has a lid, so we have a lid right there. You could actually even use a plastic bottle of water or something like that, but a glass bottle usually works a little bit better. You need some blue food coloring because we want to make our ocean blue. You'll need some water, that's what this is for, and you'll need something to represent a boat. In this case, I'm using a pecan. You'll see why I'm doing it in a second, and you'll be able to play around with what you actually put in there, but for now we're going to use a pecan. So what we're going to do is take some of the stuff and put it away here. We'll put our safety glasses on. You do always want to make sure with all of these little demonstrations that you get permission from an adult if you're a youngster watching this, because we have food coloring, we have oil, we have things that make some mess. So we want to make sure and get permission. So what we want to do is just take our bottle and we want to put water in that bottle. So let's pour it in there. How much water do you need? Well, you don't want half and half. You don't want half water and half oil. It looks a little bit better if there is a little less water than oil. So something like that. So maybe 1/4 of the bottle is going to be water, 1/5, something like this. So we have a little bit of water in the bottle. Now, we usually want a blue ocean, right? So let's take some blue food coloring, put 1 drop in there. 1 drop's probably going to be enough. Let's check it out. So there's our 1 drop. Put the cap of the food coloring on. You can kind of see that blue food coloring spreading out. It's kind of neat anyway. We'll swirl it around. That's a nice ocean blue. So I'm very happy with that color, so I'm going to leave that the way it is. Now for the next step, I'm actually going to put my ocean in a bottle right on top of a plate, because what I really want to do when I put my oil in is I want to fill it all the way up to the top, as close as I can get to the very, very top. I really don't want to have very much air at the top, and it'll work either way, but the more oil you can fit, the better it'll look. So that's why I have a plate to catch anything that might spill. You really don't want it to overflow because it gets sticky and messy and just not a lot of fun. So let's go ahead and pour this in. And you can see the oil is of course floating on the top. And I am going to leave a little bit of a gap because I need to put my pecan in. So go ahead and fill it up. I'm leaving a little bit in the top here. And let me go ahead and cap it off just to show you what we have here. So let me take this plate away. All right, so we have a basic ocean in a bottle right now. Now, it doesn't look that impressive yet because there's bubbles running around here inside of the oil, and we'll fix all that in a little bit as everything settles. But basically what you have is oil floating on top of water. So as you turn it to the side, you should see a nice little illusion and look like a little ocean as the ocean waves go back and forth. Now, you see what I'm talking about with this bubble at the top? That kind of takes away from the whole thing. It kind of makes it look like it's an illusion, which it is, so it's not quite as cool. So we're going to fix that here in just a minute. But what we basically have going on here, and the reason this works, is simply because oil does not mix with water, and it floats on top of water. So the science behind this is that oil is what we call less dense than water. Now what I mean here is that the oil is floating on top of the water because it's less dense than the water. Now what does that mean? That just means if I take the same amount of oil and compare it to the same amount of water, it turns out that the oil is going to weigh less than the water. For any given amount that you look at, the oil is always going to weigh less, and that's why it floats. Anything that weighs more than water for the same volume, for the same size, is going to sink. Anything that weighs less than water for the same volume is going to float. So if I take 1 cup of oil and I take 1 cup of water and I go find out how much each of those volumes of liquid weigh, then I'm going to find out that the oil for that exact volume compared to water is going to weigh less than the same amount of water. And because it weighs less, it floats. So that's basically how all things float. You always have to compare it to water and figure out if it's less dense or more dense. Now, we have a boat, right? I don't have a real boat, so I'm going to call this pecan a boat. It's not a real boat, but it kind of looks a little bit like a boat if you try hard enough and look at it long enough. So what we're going to do is drop this pecan in here, and I want you to tell me what you think is going to happen. Well, there's a couple of possibilities. The pecan's going to float right on top of the oil on top, right? That's a possibility. Or the pecan's going to sink all the way down to the bottom of the glass. That's a possibility. Or the pecan's going to go down there and it's going to kind of rest right on top of the blue layer on top of the water and just kind of float on top of that, but it'll be underneath the oil. So how do you know which one's the right answer? Well, it depends on what is the density, how dense is this pecan. We talked about things and talked about just a minute ago what causes things to float. You basically have to compare the density of this pecan, which means how dense it is, to oil and to water. All right, so let's see what happens. Let's just drop it in there. If it is less dense than oil, it'll float on the oil. If it's more dense than oil, it'll sink through the oil. So let's see what happens. Let's drop it in. Right, and we'll put it in there, give it a second, and looks like it is going down. So the oil has coated the pecan, and the pecan is definitely starting to sink. So it looks like this pecan is more dense than oil. That means if I look at the same size oil as I have of a piece of pecan, if I look at the same amount, the same volume of a pecan compared to oil, then the pecan is going to weigh more than the oil for the same volume. But look what happens is that when it sinks down, it stops. It doesn't go into the water layer. So this means that when you look at a pecan compared to water, it's less dense than water. That means it floats. So if you take a cup of water and you put a pecan in it, it's going to float. Now we can test this right now. I have a cup of water here, just a regular old cup of water. And I have a pecan. Let's see what happens. Let's drop it in there. Well, you can see the pecan floats. We push it underneath the water, and the pecan likes to come back to the surface. It floats. So what does floating mean? We just talked about that. When you look at this, you can say because it floats that the pecan is less dense than water. Anything less dense than water floats. Anything more dense than water sinks. So obviously it's floating on the water in this cup, so it's floating on the water in this ocean as well. But it also turns out that this pecan is more dense than this oil here as well. Now that we've talked about that and we've given this ocean in a bottle time for the bubbles to settle out, and we've given the pecan time to do its thing, we're going to finish this guy up, put this guy back on top of our plate. Let's put a little bit more oil and try to get all the way to the brim as high as we can without any bubbles in there, or at least do our best. All right, so let's go ahead and put this away and see what we actually have here. We'll turn it on its side, and you can see we have a nice little ocean in a bottle. If we kind of tilt it back and forth, we can get some rolling waves. Notice the pecan, which is our boat, is floating on the blue, so it looks like it's a boat, and it's more or less clear on top, so you have a little thing that looks like an ocean. Now notice we do have a little bitty air bubble in there. I couldn't get out. You can play with it when you do it yourself and try to get every little bit of air out of there by just adding oil all the way to the top and sealing the top really well. And the more you can do that, the better it'll look. But this looks pretty darn good. So what you have here is sort of an illusion. It looks like an ocean just because the top liquid, which is the oil, is pretty transparent. It has a little bit of an orange tint to it, but it's pretty transparent. The water looks blue, and after you let all those bubbles settle out, it looks like it's floating on a little ocean. So kids have a lot of fun with this. You know, you can just make this. Make sure and seal the top with some kind of candle wax or tape or something to kind of keep it from ever spilling, and you'll have something that they can use and play with, you know, for a long time. And you don't even have to tilt it on the side. I mean, you can just kind of do it like this and see the pecan kind of tumbling in the waves down below. So what you have here is something really neat because it's something fun to build, it's something fun to play with, and it has scientific principles in there. So make sure you take the time to understand what's going on here. You have oil that's floating on top of water. That means the oil is less dense than the water. Anything less dense than water floats on water. When we drop the pecan in, we have the pecan sinking through the oil but floating on top of the water. That means the pecan is more dense than oil, so it sinks through the oil, but as soon as it hits the water, it floats on there because it's less dense than the water. And we talked about what density is, and that's just kind of a measure of how much something weighs or how much mass is in something per unit or per amount of volume, per how much stuff you have. It's a kind of a measure of how compacted something is. So this pecan, when compared to oil, is more dense, it's more compacted, it's more massive for the same space than the oil, but when it hits the water, it floats on water because it's less dense than the water. I'm Jason with scienceandmath.com. I hope you've enjoyed this. Go put it together, go do it. It just takes a few minutes and it's a lot of fun, and there's a lot of really good science to learn in here as well.